Hello, dear students. This is Mr. Chung, and in this video, we're going to solve for the missing sides of similar triangles. So let's look at problem number 1. It says triangle CBA is similar to triangle TUV. So the first thing that I want to show you is that the letters tell us which sides correspond. So they tell us they're similar because they have that squiggly in the middle. So let's use green for the first. So it's a CBA. So we start from C and go to B. And then, so B to A. And so then our last one is going to be AC. Okay, so CBA, I use green, blue, then orange. And that's similar to TUV. So once again, I'm going to start at the T. And then this time, so TUV, I use green, TU, and then U to V. And then I'll know that my last corresponding pair is the orange. So now the blues correspond, the greens correspond, the oranges correspond. As you can see, they go from biggest to smallest. The blues are the biggest. I think to me, it looks like the blues are the biggest, the greens are the middle, orange are smallest, but those are the corresponding sides. Okay, now how do we find that missing question mark right there that I highlighted in yellow? So from your textbook, let's look at the method. It says we got to set up a proportional equation. Now, proportional equations can compare two pairs of corresponding parts, sides, of similar shapes. So this is the first method that we're going to use. We're going to compare two pairs of corresponding parts of the similar shapes. What does that mean for our picture? Well, it just means that I'm going to compare either the greens, the blues, or the oranges. Okay, so the way that I'm going to do this, is I'm going to look at this one as our original and the second one as our new. Or maybe, well, it doesn't matter. So let's say that was our original and it got blown up to being the new one. So we're always going to do new over original. And when it says we compare two pairs of corresponding sides of similar shapes, it means that I'm going to take something from the new and compare it to the original. So if I were to use the green, I could say the new is 42 over the original, and we could call that X because we don't know what it is. And we could say from the new, let's take the 21 because that's the only other number we have. So that's orange, and divided by the original, which is 6. Okay, so now you've set up your proportional equation, and the way you're going to find X is you're going to just do the butterfly method. The butterfly method is when you multiply. It's also called cross multiplication, but you are going to circle this part of the equations and then this part, and you're going to multiply them. So let me undo the second one. So the first thing we do, we're going to multiply 42 times 6, and that's going to equal 2. Then we multiply X times 21. 21 times X. And that's just going to give us, use my calculator just so I don't make any mistakes here. 42 times 6 is 252. That's going to equal 21X. And then finally, you're gonna divide both sides by 21. So divide by 21, divide by 21. The 21s cancel out. X is gonna be 252 divided by 21, which is 12. So this is gonna be 12. Okay, now this makes sense because we could find the zoom factor by dividing new over old. So 42 divided by 12 is going to equal to 3.5. So this is our zoom factor. And that means if we multiply every side of our original by 3.5, we should get the new. So let's try it out. 12 times 3.5. If you put it into your calculator, that's going to equal 42. And then if you say 6 times 3.5, if you put it into your calculator, you're going to get 21. And so it works out. All right, so now I want you to go ahead and copy down problem number 2 onto your paper. You should have taken notes on problem 1, and then try to solve for this problem using the method that we just did. So I want you to compare the new over the original for your proportions. Okay, pause the video and do that. Your final answer should have been 35. Okay, if you did not get 35, then you did the problem incorrectly. So go ahead and check your answer and redo it if you need to. Rewatch the beginning if you need to. Now let's do a second example. Problem number 3. So proportional equations can compare two pairs of corresponding parts of similar shapes, or can compare two parts of one shape to the corresponding parts of another shape. So what does that mean? Okay, let's label our corresponding sides first. Let's start with triangle BCD. So they say BCD. So start from B to C, and then C to D is similar. Let me finish off that triangle. So that's similar to BKL. So let's start with blue again. B to K, and then K to L, and then finally L to B. So now we've labeled the corresponding sides. So we know which sides are going to match. And what you're going to do now is you're going to put two sides of a single triangle into a fraction. So for example, if we go blue over green, we're going to say for this one, we're going to say 12 over 8 is equal. And then you're going to find the blue to 18 over x. And this would still work if you went green over blue. I just decided to go blue over green. Actually, for our sake, let's just fix that up and let's do it the other way, because on example 1, we had x on the bottom. Let's put x on the top. So let's do green over blue. So we'll have 8 over 12 is equal to x over 18. So now, once again, what are you going to do? Pause the video and try to figure that out. If you said we're going to cross multiply this 12 times x, 12 times x, and then cross multiply 8 times 18, 8 times 18, you'd be right. And you just get 12x equals to 8 times 18, 144. divide both sides by 12, and x becomes 12. Okay, now pause the video and copy down challenge problem number 4 and do that on your own. All right, if you got the answer of 16, you'd be correct. If you did not get 16, that means you did it incorrectly. Go back, rewatch the video, check it again. And a final thing I'm going to do is I'm going to just kind of highlight the colors that we did. So we said on this one, we compared the new to over the original, right? So, and we did green over orange. So we did green over orange, and we made that equal to 42 over, oh, sorry. So that's not what we did. On this one, it's the first method, right? First method. So what we did was we did the new green over the original green. And then we did the new orange over the original orange, okay? So that was the first method. In the second one, we did the 8 over 12. So we did the 8 over the 12 of the same figure. And then we did the x over the 18 of the same figure. So notice how the green is across from each other. The same color is across. And then the 12 and 18 are both blue, same color across. And for the first one, we had the same color up and down in one fraction. So for green, 42 over x, and then we had orange, 21 over 6. So either way works as long as you're matching them correctly. All right, over and out.